Good morning, everybody. Right now it is bright and early, so I am hoping that this is going to be one of the easiest lessons for you, solving and graphing one-step inequalities. So I've left an example up here for you because this should look familiar to you. Remember when we did equations, whatever you do to one side of the equal sign, you do to the other in order to keep that balance and to get that x alone on one side. What do you notice here? It's not an equal sign. It's a greater than or less than, or it's a greater than or equal to sign. But we treat it the same as we would if it were an equal sign, just keeping that same symbol. So we have x plus 7 is greater than or equal to 10. How do I get x alone? I remove the 7 from this side, so I have to take 7 away from this side. That gives us x is greater than or equal to 3. Now we worked on graphing yesterday, so you get more practice today. Remember, if it has that partly equal sign in there, we are going to graph a closed dot on 3. Because the numbers that could fit this inequality, x is greater than or equal than 3, 3 could fit that. If I were to substitute the 3 for the x, because 3 is equal to 3. That's part of that inequality expression. Now, which way am I going to graph on the number line? I am going to graph to the right because the numbers are greater than 3, equal to or greater. So when I graph to the right, every single number that's greater than 3, including 3, will fit in this inequality. So let's try it. Is 4 greater than or equal to 3? Yes. Is 5 greater than or equal to 3? Yes. I'm going to try 3.5, which would be right there. Is 3.5 greater than or equal to 3? Yes. So this is my solution, and this is what it looks like graph. Again, remember, we have a closed dot that would include the 3, and the arrow goes to the right this way because it's greater than. Notice that this is going this way, so we go that way on the number line. All right, let's try this one, number 2. X minus 3 is less than 9. So what's the opposite of subtracting 3? Adding 3. So I'm going to add 3 to both sides of the inequality. 3 cancels out. I have x left on this side. I bring down my inequality, and then I add these together. So my solution is x is less than 12. Oops, I don't have 12 on here. So I'm going to renumber my number line, and I'm going to put 12 in the middle, because that will give me space to either make all my numbers greater than 12 or all my numbers less than 12. And this tells me x is less than 12. So that is not going to include 12. So I have to have an open dot on my graph. And I can see the arrows going to the right. That means less than. All the numbers less than 12 go to the right. So that's my graph, and that's my solution. All right, so the next inequality is 5x is less than or equal to 45. We have to remember what this operation means. 5x means 5 times some unknown number. The opposite of multiplying by 5 is dividing by 5. And remember that this fraction bar also is a division bar. So I divide by 5 on both sides of the inequality. 5 divided by 5 is 1, so that cancels out. That leaves x alone is less than or equal to 45 divided by 5 is 9. So I'm going to look at my graph. I notice that it's less than or equal to, so that equal to part tells me 9 could be a possible solution here. X could be 9 because 9 is less than or equal to 9, and it fits that part of this symbol. 9 is equal to 9. All right, my arrow's going to the left. So I'm going to graph all these numbers to the left. So I'm going to try them. Is 8 less than or equal to 9? Yes. Is 7 less than or equal to 9? Yes. Let me try some numbers between 8 and 9. Is 8.9 less than or equal to 9? Yes. So every number less than or equal to 9 would fit in the solution. So again, let me remind you that inequalities have more than one solution. Equals or equations would only have one solution. All right, do you recognize that? That is our division problem. It means x divided by 8 is greater than 3. So what's the opposite or inverse of dividing by 8? Multiplying by 8. So I'm going to show my multiplication on both sides. And don't forget, 8 over 1 is an improper fraction. That's how we eliminate those 8's on the left side. That leaves me x is greater than, multiply that side by 8 too, and you get 24. So go ahead and try to graph it. Stop the video before I show you, and then turn it back on and see if you got it right. Okay, and there's your graph solution. Okay, we're going to take a look at a word problem, your favorite. And the star of the show is Cora. Cora's making party favors for each of her 7 friends attending her birthday party. She does not want to spend more than $42. So think about it. Can she spend $43? No. Can she spend $42? Yeah, no. Or she doesn't want to spend any more than 42, so 42 is okay. 41 is okay. $41.99 is okay, and so on. So we're going to write and solve an inequality to find the maximum cost for each party favor. So we have some clues in here of how we're going to write this problem. What we want to do is figure out what our unknown is. So our unknown is C. What is the cost of each favor? Okay. And how can we kind of look at this and rephrase it? So she has 7 friends, right? The cost of each party favor we don't know, but each party favor will be 7. There will be 7 for each of her friends. She does not want to spend any more than $42. Why did I make a less than or equal sign? Because I can't go over $42. So be careful when you see this word maximum or more than. Don't automatically assume that it's going to be a greater than sign. Think about the situation. All right, so we can solve this. This is a multiplication problem. And we want to isolate our variable. So what's the opposite of multiplying by 7? Dividing by 7. Do the same thing to both sides of our inequality. Cancel out your 7's. We have C by itself is less than or equal to 6. So this tells us Cora can spend no more than $6 on each favor. Because if she spent more than $6, she would end up going over $42, and that's all she has to spend. So I hope this helped you. Go ahead and get your homework started, and let me know if you have any questions. Have a great day.